Hello everyone, welcome to the channel. In this video, we are going to be evaluating the trigonometric integral of sine to the fifth power times cosine squared d theta. So to get started, the first thing that you're going to want to do is you want to use one of your trig identities. Well, you want to break apart this sine to the fifth power and then use a trig identity to convert it to cosine. So this is going to be sine to the fourth theta cosine squared of theta sine theta d theta. Now you'll see why in a second, why we're choosing to do this. But before we go to that next step, let me just go ahead and rewrite this as sine squared theta all squared times cosine squared theta times sine theta d theta. And then one more time, I'm going to use the trig identity of cosine squared plus sine squared equals 1. So that means, that trig identity is cosine squared plus sine squared equals 1. And then if we solve for sine squared, we get sine squared theta equals 1 minus cosine squared theta. So I'm going to plug this in, this whole term right here, in for sine squared. So then we have the quantity 1 minus cosine squared theta all squared times cosine squared theta sine theta d theta. Next, I'm going to make a u-sub, and if I challenge you to take a moment to try and figure out what the u-sub is going to be. This is where you kind of need to just kind of start building an intuition about it by just working a lot of problems. So I'm going to let you. So if you want to pause it, try and figure it out. If not, let's just keep going. So I'm going to let u equal cosine theta. That means du is equal to negative sine theta d theta. Now, I have a sine theta d theta right here. So I want to get that alone in this du statement. So then that is negative du is equal to sine theta d theta. Now, here we have a match for this. Okay? Then our u statement, u equals cosine theta, everything else left in the integram is a cosine of a power, right? So then so now we're ready to do our u-sub. You cannot perform the u-sub and then still have some components of the previous variable left in there. You need to do everything at once. So now we're going to substitute this sine of theta, d theta, for a negative du. And we're going to substitute this cosine squared and this cosine squared for u equals cosine. So those are going to become u squared. So we're going to have the integral of the quantity 1 minus u squared all squared times u squared, and then this is going to be a negative, so I'll just put negative 1 du, but this is the same as negative because we could pull a constant out. So this is the integral, so the negative integral of 1 minus u squared squared times u squared du. Okay? So you can expand this out and then multiply the u in, Or you can recognize that to get to that term, if you have a u minus u cubed all squared, that's the same as 1 minus u squared times u all squared, right? So then what I'm going to, and then this is the same as 1 minus u squared all squared times u squared, right? So I'm just going to multiply, I'm just going to bring this u back in, recognizing that I have to drop this power down to 1 because it was previously 1. And then when we squared it and when we pulled it out, we got the square, right? So I'm going to insert this term in for these two, for that whole product, right? Well, before we do that, if you want, you can go ahead and do the expansion of this, which will be helpful. So let's go ahead and do that. So that's going to be u minus u cubed times u minus u cubed, which is equal to, now we're just going to use FOIL here. So this is u squared minus u to the fourth minus u to the fourth plus u. Now we're multiplying here, so we're adding exponents. 3 plus 3 is 6, which is equal to, in descending order of exponents, so it's going to be u to the sixth minus 2u to the fourth plus u squared. So this will be our new integrand term, right? So let's go ahead and write that integral again. So don't forget this negative that we have here. So this is going to be negative integral of u to the sixth minus 2u to the fourth plus u squared du. And you can break this up because this is basically addition and subtraction. So let's go ahead and separate these into different integrals in case this is a little too much for you to do at once. So you can go right ahead and separate these. Now remember this negative, right? So I'm going to do it like this. A negative, I'm going to open up a big bracket, big brace, whatever you want to call it. And I'm going to do integral u to the sixth du minus, so it's this minus, integral, so I'm going to pull this 2 out because it's a constant, 2 times the integral u to the 4 du plus, which is this plus, the integral u squared du, and then close my bracket brace, whatever. Now this is just going to be antiderivative power rule, right? So this is just going to be like, you're going to use this rule. X to the n goes to x to the n plus 1 all over n plus 1, right? So let's go ahead and evaluate those integrals. So we're going to have negative u to the sixth, so our n is 6, so that means it's going to be 6 plus 1 over 6 plus 1. That's going to be u to the seventh over 7 minus 2 times u to the 4 plus 1, so that's going to be u to the fifth over 5 plus u to the 2 plus 1, which is 3, all over 3. Okay, so then we can go ahead and distribute this negative right here in and flip these signs. So this is going to be negative 1/7 u to the 7th plus 2/5 u to the 5th minus 1/3 u to the 3rd. Now, this is all in terms of u, so don't forget, we need to go back and we need to plug in our u equals cosine theta. All right, so now let's go back in and plug those in. So then we have -1/7 times u, which is equal to cosine theta to the 7th. So this is going to be cosine to the 7th of theta plus 2/5 times cosine to the 5th of theta minus 1/3 cosine to the 3rd of theta. And this will be your answer. Well, let's not forget plus c, because this is an indefinite interval. We don't have any limits of integration. So don't forget that plus c. This will be your answer. So if you have any questions, comments, or concerns, let me know. If there's any problems you want me to do, feel free to send me an email at request@athan.com with a screenshot of the problem or what's tripping you up or whatever. And I'll try to get a video put out on that as soon as I can, especially, if you mention it's for an upcoming test or whatever. Yeah, so let me know what you think. I'll just keep pumping out some more videos so you can get some more practice and seeing some of these things, and we'll go from there. Talk to you soon.